sorry. Quick little beep there. That was me. Oh, goodness gracious. Oh, if anyone in the class needs a calculator, I have some. If not, you guys, I put at home, I put that link to that Desmos one. That's one pretty good. About 30 more seconds. Oh. Thankfully, it looks like there's not a lot of teachers out today, so that means hopefully people are getting healthier. I feel like after Christmas, it was just like a disaster. So. All right, so I'm going to start to look at this one. If nothing else, you write it down because that's how you get credit for today. And P.S., people in class, I'm checking your notes too, so just make sure you're taking them. Just to kind of keep everyone on the same playing field. If I'm checking the people at home, I'm checking the people in class. Because I'll give you guys all credit for doing it. So please make sure you're writing stuff down, no matter where you are. So we talked last week, if they were in different directions, south and north, we are going to add the angles to get our angle between them. If they were in the same direction, you would subtract them. So just as a heads up, we had written that down last week, but if you referred back, great. If you just remembered, fabulous. So for the angle, I'm going to add 80 degrees plus 70 degrees to get 150 degrees. So that's the angle between those two cities. But for us, and I need to plug into that formula. To do so, I'm going to have to convert this to radians. You know, you'll probably notice we do this like almost every problem, I feel like. So we were kind of hopefully into the habit of doing it. I'm going to multiply by pi over 180. At that point, if you can just kind of throw it in a calculator, go for it. I always try to kind of write out my steps just so you see what I'm doing. And then from there, I am going to reduce that. And that's going to give me 5 pi over 6. So this is the angle I'll be using because it's in radians. That's what we need. So now I am going to put it in my formula. S equals R is 6,400. Theta is 5 pi over 6. So you put in the radian. And then you just grab your calculator, throw that in. Sorry, that's like an awkward 5. Awkward looking 5. So I'm just going to put it right in. I'm going to put the pi in with it. So I'm going to find that pi button and plug it in. Because if not, it's just kind of weird if it's in terms of pi. And then that's going to give us a distance. It's a big distance, right? Because there's a lot of room between those two cities, and it's 16,755.16 kilometers. There you go. So I'll leave that up for a minute because I know it takes a second to write stuff down. But that's a review of last week. Just to make sure we are all on the same page. Maybe probably tomorrow we'll kind of talk about, at some point you're going to have an assessment with maybe a few of these. We'll decide if we want to have it before term 2 or after term 2 because it doesn't matter to me. We'll kind of look and see if people need a little grade booster and go from there. Okay, so that was a review from Friday. Yeah, Friday. Today we're going to look at a new type of problem. I just call them clock problems. They have to do with the clock. So magical. The nice thing is you use the same exact formula. So it's just a little bit of a different setup, but we are still using that S equals R theta. So I'm kind of working off this worksheet once again, but I'll write everything, all like the important info up. If you don't have it at home, if you have it here, you can just write on the worksheet, or you can write in your notes, whatever you would like to do is good with me. Okay. So we're in school, so we can actually look at the clock. If you're at home, you might not have a clock in front of you. but you can kind of probably visualize one. So we are trying to find the distance traveled by either the hour hand or the minute hand of a clock. So, I mean, we can actually look at it like we know, for every minute, the minute hand moves, for every hour, the hour hand moves, all fun stuff like that. If you, clocks actually have to be pretty exact because you want them to be the correct time, and to do that, you need it to move a certain degree every minute or hour, so it lines up. It's all actually math. I know you don't really think of it that way, but there you go. So the first thing it says is, what's the arc length formula? We know it. It's S equals R theta. But just as a reminder, this is what we're using. And theta has to be in radians. Okay, I've reminded you that every time. We'll see if we can all remember. So when it says arc length formula, you're just writing that. And then it says how to find the angle formed by clock hands. So we have two scenarios we're talking about. We're talking about either the hour hand or the minute hand. So depending on which we're using, your info changes a little bit. So when we think about a clock, I'm just thinking of kind of looking at it and look at one rotation around. There's 12 hours in one rotation. Right, so if you look at a clock, it goes from 12 and then it goes up to 12. And if I rotate around, it's 12 hours, and then it kind of just keeps repeating after that. Now, if we think about one rotation around a circle, we know that that's 360 degrees. So if I take 360 degrees and divide it by 12, that's going to give me the angle that I need. And the angle that I need is 1 hour is 30 degrees, okay? So every time, like if the hour hand goes from 1 to 2, or 2 to 3, or 3 to 4, whatever, it's moving 30 degrees every hour to go in that full rotation. Yep.
Would you mind writing a little bigger, please?
Oh, yeah.
Thank you.
Yeah, absolutely.
That says 360 over 12.
360 over 12, because there's 12 hours in one rotation, so 1 hour is 30 degrees. Absolutely. Yeah, always tell me, because I'm up here and then I can see it, so sometimes I forget that people are far away. Okay, so basically that's all this stuff is fine. This is what you need to know. Okay, that 1 hour is 30 degrees. If you know that, you're good. So the minute hand is kind of same idea, but when we think about one rotation around, there's more than 12 minutes, right? One rotation around is 60 minutes. So there's 60 minutes in one rotation around. So kind of, you have to remind yourself the hour hand and the minute hand are kind of independent. So when I think about that, if I have 360 degrees, one rotation, and I divide it by 60 degrees, that's how much each the minute hand moves each minute. And that will come out to 1 minute is 6 degrees. Those are the two things. You don't even need to know them. You just write them down so we can refer back to them. But those are the little angles that we're going to be kind of using. So I'll give you a second to write it, because once I know if you're here or if you're at home, I tend to just fly through things. I want to give you time to actually write it. So then we're going to look at example 1. So if you're at home and you don't have the worksheet, I'll write down kind of the important information. I am going to kind of erase this and just rewrite the important stuff. So that was more just the explanation of where we're getting the angles from. The main thing I need is that 1 hour is 30 degrees and 1 minute is 6 degrees. So I'm erasing that in a second, just so I have a little bit more room. Doing something good. So I'm just going to write kind of at the top here. Just as a reminder, that's just writing on myself. That's the formula I'm using, and then I'll just write 1 hour is 30 degrees, 1 minute is 6 degrees. Okay, so that's the important stuff that I need. So now we'll do example 1. So for the people at home, if you don't have this printed, I'll just kind of write the important information. The minute hand of a clock is 8 centimeters long. So the minute hand is 8 centimeters. So when you think about a clock, the minute hand is like that. That's going to be your radius. So this is my R. Okay, so that's pretty easy. I always like the R. It's kind of just given to you. The big thing to look for is what hand you're using. So once we see minute hand, we're just going to remind ourselves of that important information up there. We'll use that in a second. But always just look, is it minute or hour? Find the distance traveled by the tip of the minute hand after 42 minutes. So we want to find the distance after 42 minutes. Okay, so I just wanted to write that important info for the peeps at home if you didn't have it printed. So here's what you do. We're using S equals R theta. We have R, so we're good. We need to find theta. So that's our main goal, basically. So for us, or if you have the worksheet, A says find the angle formed by the minute hand. So I'm going to take 42 minutes, but I want an angle. Every minute is 6 degrees, so I'm just going to take the minutes and multiply it by 6 degrees. That's going to give me an angle, so that's my main thing. Minute hand or hour hand, that tells you what you're multiplying by, and then you just kind of multiply by that. And that's going to give me 252 degrees. All right. So that was A for the people that have the worksheet. For B, it says convert that to radians. We always need radians with our nice little formula there. So for B, I'm going to take 252 degrees, and I'm going to multiply it by pi over 180. Once again, I feel like we do this step quite a bit. So we hopefully should be semi-used to it now. I like to rewrite it like that, and then I'm just going to grab my calculator and reduce that. So 252 over 180 is 7 pi over 5. And that's going to be the theta that I'm using, so I'll just remind myself. Part C says plug into the formula. So now just take S equals R theta, because we have R, and we now have theta, and plug them in. So S equals R is 8. Theta is 7 pi over 5. And then once I plug that in, I'm going to get an answer that I'm going to label. Remember for this one, I'm going to plug the pi in. So I just want a decimal answer, because just in context, it makes a little bit more sense. So 8 times 7 pi over 5 comes out to about 35.19. I usually round to 2 decimal places, centimeters. Man, that little, just in 42 minutes it travels that far. Think about all the work those clocks do during the day, just to keep us on time. What time is it? It's Monday. So I'll leave that up for a second. The main goal is finding that angle. So just thinking, is it minute hand or hour hand? And then you basically just take it and multiply that by either the 30 or the 6. And that will give you your angle that you convert to radians. Your shirt. Okie dokie. So we're just going to look at example 2 and example 3. There's just like little differences between them, but same idea. And then you guys are going to try just a few of the quick ones on the back, and we'll save a bunch of these for tomorrow. Once again, I kind of went into this thinking like, yeah, we'll like fly through this. I don't want to rush, so we can do this over 2 days. We'll survive. I'd rather kind of not kill you with a million problems every day. It's okay if it's a little longer. Does anyone still need example 1? So example 2 is kind of similar. There's one little difference, but it's something that hopefully makes sense. I'll explain it to you. Example 2. The minute hand of a clock is 12 centimeters long. So the main things I want to take away from this is we're talking about the minute hand. And it told us it's 12 centimeters, which is now going to be my R. So I know what R is. So however long it is, that's kind of your radius around that circle. Find the distance traveled by the tip of the minute hand after 1 hour, 20 minutes. So I'm just writing the notes so in case people don't have the worksheet at home. After 1 hour, 20 minutes. The big thing I wanted to point out here is since we're talking about the minute hand, this has to be just in minutes. We don't really want hours. So we know that every hour is 60 minutes, right? Plus we have 20 extra minutes. So we're actually going to say that the time is 80 minutes. Okay, well it helps if I actually write 80, I just write 80 minutes, okay. So if you're talking about the minute hand, it has to just be in minutes. So if you see hours, then you just have to make them into minutes and then kind of add them together. So what we need to do for the first part A is find the angle. So we just said it was 80 minutes, but we want an angle. We don't just want a time. And to find the angle for minutes, for the minute hand, we're going to multiply by 6. And that's going to give me the angle of 480 degrees. So that's the first part that you're always doing. You actually have to find an angle. It's just saying 80 minutes doesn't really tell you anything. Okay, so we have an angle, exciting stuff. For part B, it says convert this to radians. So I'm going to multiply by pi over 180. Once again, I'm kind of writing the steps out. If you're just doing it in your calculator from there, go for it. That is usually what I do, but I like to kind of show you my process here. So 480 over 180 reduces to 8 pi over 3. So this is now my theta. So I have R, I have theta. I'm going to plug in. Kind of running out of room here, so I'm going to do it next to it. So S equals R theta. So S is going to equal, R was 12, and theta was 8 pi over 3. And then I just use my calculator. 12 times 8 pi over 3. I'm plugging the pi in just so I get a decimal answer, and it comes out to about 100.53. And then when I say label it, the original was in centimeters, so this is also in centimeters. Man. So poor little minute hand's working hard, and an hour and 20 minutes to travel 100 centimeters. There you go. So I'll leave that up for a second. Please let me know if you have any problems. We're going to do example 3, and then you guys are going to try just quick little ones on the back, just to see that you're on the right track. All right, so example 3, I'm just going to read through it. I'll erase this in a second. 3 is talking about an hour hand, so it's going to switch a little bit, so that's why it's kind of good to just remind yourself what you're looking at. It's 4 inches long, so that's going to be our radius of the kind of little circle for the hour hand. Find the distance traveled by the tip of the hour hand after 7 hours. Okay, so our measurements are going to be a little bit different. Once again, we're talking about an hour hand, which we know doesn't rotate the same as a minute hand. You just got to be careful. That's why I kind of like to keep this at the top, just to kind of remind me what the heck I'm doing. And you're gonna see every time I'll either underline or just remind myself that I'm talking about, in this case, the hour hand. So this is example 3. So it tells me the hour hand is 12 centimeters. So that's gonna be my R. So I got R. I need to find theta. Excuse me. My first step is, okay, well, how long? It was find the distance after 7 hours.
I think, wouldn't R be 4?
Oh my God, where did I just get 12 from? I was looking at
You
example
probably got it
2.
from
No,
the-
you're totally right. Thank you. That's 4. I was looking at example 2. I don't know what I was just doing. Yes, please always tell me when I'm wrong. It happens quite often. Okay, 7 hours. Take your hours. Since we're talking about the hour hand, we want it in hours. And since we're talking about hours, we're multiplying it by 30 this time, so it's a little different. It's just what you're multiplying by is different. All the other steps are the same. So that gives me 210 degrees. For the second step for part B, it says convert that to radians. So I just grab my calculator and I'm going to multiply it by pi over 180. And then once that's kind of multiplied out, I'm going to reduce it. Use your calculator, use an online calculator, use, I don't care, anything that's going to reduce the fraction for you, but don't put the pi in. So we leave those in terms of pi. 7 pi over 6 is now my theta. All right, so now we just plug in. The actual plug in is like the easiest part, I feel like. It's just getting to that point where you have all the information. R is 4, theta is 7 pi over 6. And that's going to give us our S once we plug in. This case, we do plug the pi in. So we just want a decimal answer because decimals, it kind of makes more sense in our head. And that would be about 14.66. Is this in centimeters? Is this in inches? This one should be inches. I'm sorry. I was looking at the thing. I knew it was. Inches. Sorry. Sharma, what's wrong? A little crazy in the morning. Okay, so basically everything's the same, whether it's hour or minute. Just make a note to yourself which one it is, because that will just affect when you're finding the angle what you multiply by. That's like the big difference. So I like to kind of have that little cheat sheet up at the top just to remind me what the angles are. So we have about 15 minutes left. So I kind of have to give you a little extra time, especially at home, because I'm having you do it and then upload it, and I know that it can take a minute or 2. So I'm looking, if you have the worksheet in front of you, great. If not, I'll write these out on the board in a second. I'm looking at numbers 1 through 4 on the back. They're actually super quick because you don't actually have to solve for everything. All you're doing is finding the angle. Because I feel like that's the most important part. All the other parts we've done like a million times. So you're focusing on, am I talking about the minute hand or the hour hand? Excuse me, and then what am I multiplying by? You can just give me the angle in degrees, that's fine. But that's the step we want to make sure we're good with, because if not, it kind of messes up the rest of your problem. So let me write 1 through 4 out, and then at home I'm just going to give you directions about how to turn in your work and go from there. But just make sure you're staying on. Okay. I guess I probably shouldn't erase that, but you guys should have that written down by now. So for you guys, you're just finding the angle. And it can be right in degrees. You don't have to do anything fancy with converting it. It's more just like, do you understand the process? So number 1, if I said I had the minute hand and it was traveling 18 minutes, can you tell me the angle that would form on the clock? So remember, minute hand times 6 degrees. Number 2, it's the hour hand and it's traveling for 4 hours. So remember, hour hand, it switches, and you're going to multiply that one by 30 degrees, and then you'll get your angle. So those ones are pretty quick. Number 2, it says minute hand. And it's traveling for 2 hours, 5 minutes. So before you multiply it by the 6 degrees, you need to make sure this entire thing is just in minutes. So convert that to minutes first and then multiply it. And then last but not least is the hour hand. And it's traveling for 1 hour, 30 minutes. We want to make sure it's in terms of hours though. So you wouldn't write 1 hour, 30 minutes. You wouldn't write 90 minutes. That doesn't make sense because it's an hour. So for an hour, 30 minutes is half of an hour. So you would write it as 1.5 hours and then multiply by 30. So do your best, try those. You don't have to do anything other than that. So you don't have to actually plug it in. It's just finding the angle. So give me 1 second. I just want to, I'm just going to stop.